Hello, I have Abby here with me to do our next equivalence lesson for you. Now, we've talked a lot about equivalence. We learned some other words too. We've learned congruent and similar, and then we started working on equivalence. And equivalence is really fun because you can be really creative with it. Can you give us a reminder of what it means for two shapes to be equivalent?
They have the same space.
They take up the same space. So they can be the same shape that take up the same space, or they can be different shapes arranged that take up the same space. Okay, so I grabbed another material out of our fraction cabinet or geometry cabinet, and this one is really interesting. And you might have had this lesson before, but if you have, this is review, and if you haven't, this is really fun. Okay, Abby, can you help me identify the different shapes that are on this piece?
Rectangle, triangle.
So here we have a triangle made out of red pieces, and there's 3 pieces in there, but we're just looking that it makes a triangle. And then the empty frame is a rectangle. Okay, now we need to talk about the parts of these shapes. Now, this might be review or it might be new. This bottom, the bottom of a figure, like this triangle right here, this is called the base. And the bottom of this rectangle is called
the base.
The base. They have the same name for the bottom of the figure. It'd be the same if this was a different shape as well. The bottom, where it sits, is called the base. Okay, now, do you remember the word for what this is, the dimension that goes up?
The height.
The height. Okay, I'm gonna move this out of the way, and I want to look at this. If I move this piece down, right like that, the line that's created right there, or I can turn it this way so you can see it a little more clearly. This line that I made right down through the center there is the height of the triangle. The height of the triangle goes from the base to the tallest point. The height is from the tallest point to the base. Okay, I'm gonna rebuild this triangle. Okay, now that we've remembered or reviewed the things we already know about triangles and rectangles and their parts here, now I have a question. I'm wondering if this triangle is equivalent to that rectangle. Is there a way we could check that easily?
If we broke the triangle into parts.
If we took the parts of the triangle and filled the rectangle, can you do that and show me if it's equivalent, if it takes up the same space? She did it. This triangle, the pieces that made up the triangle, filled up this rectangle, the same pieces. So this triangle is equivalent to this rectangle. Okay, now we just practiced looking at the parts. So let's look at the parts. This is the base of the triangle. And what did the base of the triangle become?
The base of the rectangle.
The base of the rectangle, this length right here. Right here, this is the base of the rectangle. Now, the height of the triangle was found just like this whole length. So if this is the height of the triangle, and we just move this piece over, how is that related to the height of the rectangle?
It's just one of these pieces.
It's one of them, so it's half as tall. Let's put that piece in. The base of the triangle is the same as this rectangle, but the height is cut in half. This is half the height of the triangle. Okay. We can summarize equivalence of triangles and rectangles really easily. A triangle is equivalent to a rectangle when they have the same base and the triangle is twice as tall as the rectangle. You could say it a different way. The triangle and rectangle are equivalent when the base is the same and the rectangle is half as tall as the triangle. You could say it either way. Okay, I hope that you enjoyed seeing that little bit of exploration with the equivalence between triangles and rectangles. I know you saw that in our last lesson when we had the tall rectangle and the triangle, and that we turned that rectangle into the triangle. That's one way to do it as well. This is another type of triangle. That was a right triangle, and this was an equilateral triangle. So I want you to explore turning triangles into rectangles. You can cut any triangle you want. You can trace any triangle you find at home. You could even trace a rectangle you find at home and turn it into a triangle and see if you can make an equivalent triangle to your equivalent rectangle. Okay, I'm going to go ahead and share a picture or post a picture of my follow-up from this work, and I want yours to look something similar. I want you to include the title of what we're working on and the definition of the equivalence between a triangle and a rectangle. Here is mine. It says, here we go. A triangle is equivalent to a rectangle when the bases are the same and the triangle is twice as tall as the rectangle. And you can see that here. I drew a triangle that is 2 units tall and 2 units on its base. And it's equivalent to this rectangle that has 2 units on the base, but only one unit tall. They have the same base, but this height is half the height of the triangle. And there's some triangles I cut into pieces and glued into a rectangle. So you can do the exact same thing at home with whatever triangle and rectangle you have available, or you can just cut your own and explore with that. I hope you enjoyed learning the relationship between the equivalence of a triangle and a rectangle. And next time we're going to do triangles and rhombuses. I hope that I'll see you next time. Bye-bye.